So starting here to finish up 4.8, looking at example 3, these directions tell us graph each function, identify the x-intercepts and the points where the local maximums and local minimums occur, determine the intervals for which each function is increasing or decreasing. Okay, and then if you look at the solution, they talk about using a graphing calculator. You can use GeoGebra to do these. Okay, and I'll show you exactly how to do that with this problem. Okay, so the function we are going to do is f of x equals x to the fourth minus 5x cubed plus 2x squared plus 8x minus 2. Okay. So we are going to follow all those directions that they give in that example 3, and we're going to apply that to this function. Okay, so I'm going to go to GeoGebra, start graphing. I am just going to type this function in. So it is x to the fourth minus 5x to the third plus 2x to the second plus 8x minus 2. Okay. Drag that out because we don't need to worry about that right now. Okay. So notice here, okay, based on what they're asking, first of all, is it increasing or decreasing right here? It's decreasing. Remember, you're going from left to right. So as I go from left to right, I'm going down, right? Okay. So here it is increasing. Here it is. Here it is. Okay. Also notice when you do that on GeoGebra, they plotted your intercepts, right? For you. So that's nice. What else did they mark that we need? They marked our turning points as well. Okay, so they marked all our turning points as well. So what we need to do is go in and just answer the questions that our book asked us. So, first question, identify the x-intercepts. Okay, and this is the other nice thing. Because we found out the other day, and we have been doing it in the past, they're not always at nice whole numbers, right? Okay. There's my x-intercept. Okay, it gives it to us. So obviously we're going to round that number. When you're talking x-intercepts, are you looking at the x value or the y value? The x. The y's had better all be 0, right? Okay. So my intercepts. Let me grab a marker here. My x-intercepts, one of them is approximately, let's go to the nearest hundredth. Okay, negative 1.11. The next one is approximately 0.24. When you do this in big ideas, if that's a 0, make sure you put 0. If you just do 0.24, it'll count it wrong. Okay. It's got to be 0.24. The next one, approximately 1.82. And the last one, approximately 4.05. Again, those are all the x values of my intercepts. Go ahead. That means approximately, yep. Okay. Does it make sense with this function that we just looked at that there are 4 intercepts?
Yes.
Yes. Okay. Austin, can you shut that so I know you're paying attention? Thank you. Okay, so that makes sense because it was a 4th degree. Okay. The next part of the question asks, wrong part. There we go. Identify the points where the local maximums and local minimums occur. Okay, so let's take a look. Let's list the local maxes. Yes, there could be multiple local maximums. You just have to kind of understand where they're at. Is this a local maximum or minimum? Minimum. Max. And then this one down here that we don't see right now? Minimum. Okay. So so I have a local minimum at
negative 0.57 and
negative 4 point what? 88. Okay. If I were to ask you what is the minimum at that local minimum, what would you tell me? Is it the x or the y value?
The y.
It's the y value. Okay, minimum we're talking up and down. Notice this is the lowest point. Okay, it's not the furthest left point, it's the lowest point. Up and down we're talking y value. This point you told me was a local max at 1.07. 4? Okay, so that's a local maximum right there. What is that local maximum? 4.04. I wondered if it would let me do that or not. And then this one is another local minimum. At 3.25. Nearest hundredth. Nearest hundredth. Okay. So we've so far identified the x-intercepts and the local minimums and maximums. And the next thing it wants us to do is describe where this function is increasing and decreasing at. Okay. So let's just start with decreasing because that's what's happening on the far left over here. Are we okay with that? Mm-hmm. Okay, so this function is decreasing when x is left of what point? When is it decreasing?
That minimum.
This minimum right here, right? Okay, so we're going to rewrite that. It's decreasing when x, how do I say it's left? Less than. When my x is less than what?
Negative 4 point. No, you only use the 4.8, right? No.
Why is it 0.57?
That's the
X, right? This 4 is a y. Okay, so right now with what we're about to do, the y's don't matter anymore, right? Okay, so it's decreasing when it's less than negative 0.57. And it's also decreasing right here, right? Okay, so we're decreasing, increasing, decreasing. Okay, now this one's going to be a little bit trickier because this is going to be an interval between 2 points, right? Okay, and we've done this a little bit. I need to put x in between two numbers. Okay, what number is going to go on the left? 1.07. And on the right is going to be 3.25. And you can't see this on this graph, but you guys are getting it from here, right? My local minimum here. Because I know this x value of this minimum down here is 3.25. Okay, so that's when my function is decreasing. Does that satisfy everywhere that my function's going down? Mm-hmm. Okay, so now let's do the increasing. Okay? And the way your big ideas has it set up, it's going to start you like this. It's going to say it's increasing when x is greater than. So it's not necessarily going to start at the far left. Okay, so where is it increasing that is not an interval but goes on forever? On this far right over here, right? Which is greater than what? 3.25. The x value down here on this minimum is 3.25. Bless you. And when x is in between what two numbers? Negative 0.57 all the way until 1.07. Okay, and then that would be the end of that question. That satisfied everything that they asked us. Okay, so that question's got a lot of parts to it. Just go through it carefully. You're going to graph it on GeoGebra, and as long as you graph that on GeoGebra, it's going to give you all the points that you need. You just need to click on them and look at the coordinates. Okay. Now the next part of the lesson and your last example for this lesson has to do with odd and even functions. And I know I worked with some of you on these types of functions. Before our final. Okay, we worked on some odd and even functions. So we have a core concept there. And a function is even if I take my function, I change all my x's into negative x's, and it comes out as my original function. Okay, so I go in, anywhere I see an x, I change it to a negative x, and when I simplify it, just comes back out as my original function. That would be an even function. Okay? It is an odd function when I plug in negative x, and it comes out and every single sign is exactly opposite. Meaning if it was plus x squared, it's now minus x squared. If it was minus 6, it's now plus 6. If every single sign is the exact opposite, that would be an odd function. Okay. It is also possible that neither of these scenarios is true. Okay, so it will be odd, even, or neither. And I'll show you an example of each one of those. Okay? But no matter what, you're taking the x's and you're turning them into negative x's and then simplifying. Okay, so if I have this function, f of x equals x to the third minus 12x. Okay, to check whether it's odd, even, or neither, I need to change the x's to negative x's. Okay, does everybody see what I did there? Okay, what is negative x to the third power? Negative x to the third. A negative times a negative times a negative 3 times is a negative. Negative 12 times negative x. Positive 12x. So on this function, when I plugged in negative x, did I come out with the exact same function that I started with? No. Did I come out with the exact opposite on all my signs?
Yeah.
Yes. This was positive x cubed. Now it's negative x cubed. This was minus 12x. Now it's plus 12x. So is this function odd or even? This is an odd function. No, because once you start combining all your numbers, depending on how you're multiplying, you're not going to be able to tell every position, whether every position changed sign. Does that make sense? You got to be able to look at every single position individually. And I'll show you one here in a second what I'm talking about. It's going to affect whether if you have a constant, it's not going to work. So like on this next one, f of x equals x to the fourth plus x squared minus 7. That 7 is going to mess up what you're talking about. Okay. So I still have to do the exact same thing. I'm going to take all these x's and I'm going to turn them into negative x's. And after a while, you're going to be able to do this pretty quickly. Okay? Anything to an even power, any negative to an even power is going to go positive, right? Okay, so I have x to the fourth plus x squared minus 7. So looking at my original and comparing it to what I ended up with, did anything change? No, it came back out as the exact same function. So is that an odd or an even function? That's even. I plugged in negative x and I ended up back where I started. Okay. The last one I want to do, I told you I'd do one of each, so you can guess that it's going to be neither, but I'll show you why. F of x equals x to the fifth plus 9. Plug in your negative x. Negative x to the fifth power is negative x to the fifth plus 9. Looking at my original function to my new function, my x to the fifth changed signs, but my 9 did not. So is this odd, even, or neither? Neither. Okay. It either has to be exactly the same, okay, they have to be identical, or they have to be exact opposite signs on everything. Otherwise, it's going to be neither. Okay. Is it possible for a function with a constant to be odd? No, because by plugging in a negative x, I am not going to be able to change the sign on that constant, right? Because there's no x associated with it. Okay. Any questions before I let you work on that assignment? Okay, if you have questions, make sure that you let me know.